Dear students, welcome to the next lecture of Inorganic Chemistry. In this lecture, we shall discuss about the oxoacids of group 15 elements. What are oxoacids? These are the acids in which ionizable hydrogen atoms are joined to the central atom via oxygen atoms. That is, oxoacids or oxyacids contain OH linkage with the central atom. Among group 15 elements, nitrogen, phosphorus and arsenic form oxoacids. The acids of antimony and bismuth are rarely found, but their salts are known. Examples for oxoacids include HNO2, HNO3, H3PO4, etc. Naming of oxoacids. To differentiate between the oxidation state of the central atom in the oxoacid, suffixes OUS or IC are used. We will say nitrous acid, nitric acid, etc. The name of the acid will end with OUS or IC. The acids in which the central atom is in lower oxidation state are known as OUS acids, while those having the central atom with higher oxidation state will have the suffix IC. The name hypo is used as prefix while naming the acids. Hypo is used for acids in which the oxidation state of the central atom is lower than that of the central atom in corresponding OUS or IC acids. The prefixes ortho, meta and pyro are used to differentiate acids which differ in their content of water. The most highly hydroxylated acid of a particular element in a specific oxidation state is known as ortho acid. The acid that contains one water molecule less than the ortho acid is called meta acid, and pyro acid means the acid formed by the condensation of two molecules of ortho acids by removing one water molecule. Now we shall discuss about a few acids of nitrogen and phosphorus. First one is hyponitrous acid or H2N2O2. It is a weak dibasic acid. That is, there are two ionizable hydrogens in the acid. The hydrogen atoms attached to the oxygen atom are ionizable in the case of oxoacids. Next comes nitrous acid. It is HNO2 which contains one ionizable hydrogen atom, and hence it is a monobasic acid. Comparing the names nitrous acid and hyponitrous acid, we can understand that the oxidation state of nitrogen in hyponitrous acid is +1, whereas that in nitrous acid is plus 3. Nitrous acid undergoes disproportionation reaction to give nitric acid HNO3 and nitric oxide NO. The oxidation state plus 3 changes to plus 5 in nitric acid and plus 2 in NO. Nitric acid is HNO3. It is a strong monobasic acid, that is, it contains only one ionizable hydrogen atom. It exists in resonance forms. The resonance structures of nitric acid are shown in the figure. Now moving on to the oxoacids of phosphorus. First one is phosphinic acid, H3PO2. It is a moderately strong monobasic acid. In H3PO2, there are two kinds of hydrogen atoms. Ionizable hydrogen atoms, which is attached to the oxygen, and non-ionizable hydrogen atoms, which are attached to the central phosphorus atom. The pH bond is not polar because the electronegativities of phosphorus and hydrogen are almost similar. Whereas in the case of OH bond, oxygen is highly electronegative compared to hydrogen, so that the bond is polar and the release of H plus is much easily compared to the case of pH bond. The acid has a tetrahedral structure in which there is a 1 P double bond O, 2 pH bonds and 1 PO bond, and the oxygen is attached to a hydrogen atom which is ionizable. Next comes phosphonic acid. It is H3PO3. There are two ionizable hydrogen atoms. Hence, the acid is dibasic acid. The dissociation of the acid is as H3PO3 plus H2O gives H3O plus and H2PO3 minus in the first step. In the second step, H2PO3 minus plus H2O gives H3O plus HPO3 2 minus. The last hydrogen atom which is attached to the phosphorus cannot be dissociated from the molecule. Next is phosphoric acid, H3PO4, which is a tribasic acid. That is, the acid contains 3 ionizable hydrogens. H3PO4 dissociate to give H2PO4 minus. Then H2PO4 gives HPO4 2 minus. HPO4 gives PO4 3 minus. This acid also has a tetrahedral structure in which there are 3 POH bonds and 1 P double bond O. The oxidation state of phosphorus is 5 plus 5. Hypophosphoric acid or H4P2O6 contains 4 ionizable hydrogens. The structure of the acid is shown in the figure. It has a P-P linkage and each phosphorus is bonded to oxygens by double bonds, and there are two OH groups attached to each phosphorus atom. Diphosphoric acid is H4P2O7. The basicity of the acid is 4 because it has 4 ionizable hydrogens. There is a central bridging oxygen atom in diphosphoric acid. It is also called pyrophosphoric acid. That is, this acid is formed by the condensation of two molecules of phosphoric acid by removing one water molecule. So, two molecules of H3PO4 gives diphosphoric or pyrophosphoric acid plus H2O. The oxidation state of phosphorus is plus 5 in diphosphoric acid. Next is triphosphoric acid, which has the formula H5P3O10. The molecule has 5 ionizable hydrogens, thus the basicity is 5, and the oxidation state of phosphorus is also 5. Polymetphosphoric acid is a polymeric form of phosphoric acid with the general formula HPO3 n times. The cyclic trimer of phosphoric acid is cyclotrimetphosphoric acid with general formula HPO3 3 times. It has a cyclic structure with alternate phosphorus and oxygen atoms, and each phosphorus atom is bonded to an oxygen atom by double bond, and also an OH group is attached to the phosphorus atom. The hydrogens of the OH group are ionizable in nature. The oxidation state of phosphorus is plus 5 in the case of cyclotrimetphosphoric acid.